Hello Year 5 and welcome to Friday, Week 3 Maths. So we're going to do a little bit more arithmetic practice today after your test yesterday. Similarly to last week, you have got two types of questions that you can have a go at. You choose which you think is at your level. Up to 6 questions. We give yourself about 10 minutes, see how far you can get through. You'll notice there's some rounding and adjusting in there. Still quite a tricky fraction question, so see how we get on with that. In the next couple of weeks we will be going into more detail on that one if you're struggling with that. And some fractions of amounts as well, and just remembering that we find using that bar model to represent those parts can be really useful there. So if you could pause the video now so you can have a go at these. Okay, and the answers then. So just a reminder again that 11, when we're looking here at this 11 with the small 2 at the top, this is looking at 11 squared, so this means 11 times 11 is 121. We've got our calculation here where you can see we've done some rounding and adjusting, taking away 300 and adding 2 back on. We've again got our finding our equivalent fraction, so we needed to turn this into 20ths, so 5 times 4 is 20. 1 times 4 is 4, so 4 20ths add 3 20ths is 7 20ths. You can see we've got our fifths there with the same denominator underneath. And coming down the bottom then, we're definitely looking to see that written method, and again we will be recapping this in more detail as weeks go by, so please don't worry if you've forgotten how to do this one. So 5 times 8 is 40, carry over our 4 tens. 8 times 3 is 24, add 4 is 28, carry over our 200s, and 7 times 8 is 56, add 2 is 58 for that one. We can see here we're looking for 3/7 of 35. If I show you that bar model, so we've got our 35 as our whole, and we're breaking our bar into 7. So we've got 1, 2, 3, 4, 5, 6 and 7 there. So we're dividing 35 into 7s, which is 5, and we're looking at 3 of them, so the answer is 15 there. And you can see down the bottom here, if we know that 8 times 3 is equal to 24, that can help us with finding 80 times 3. So, mark those, see how you got on, and let your teacher know. So the final lesson of this week then, we've looked at addition column method, and then we've looked at using a range of different strategies in addition to ensure that we choose the most efficient, the quickest and the most accurate for us. We then looked at column subtraction yesterday, and so today we're now looking at the most efficient strategy to subtract. In order to be successful today, we probably need to do some explaining about why certain strategies are better, are more efficient than others. Mainly it's about the pace and the quickness as well as the accuracy and making sure we get it correct, laying our work out clearly and really recognising once again the value of those different digits. So 3 calculations then that you can see on the board. I would like you to have a little look at those calculations, maybe think about which is the easiest, which is the hardest. Might not necessarily just be because they are the largest numbers. Which ones do you think, yeah, you definitely need a column method for that? Have you got any other strategies though you might use for the others? Okay, so let's have a look at the first one then. We had 42,567 subtract 27,933. Yeah, I definitely think a column method is going to be the way forward for this one, Year 5. If we see here, we can see I've made the number at the bottom here with our place value counters just to remind us again. So let's start again with our 1s. 7 1s take away 3 1s is going to leave us with 4 1s, and our 6 10s take away 3 10s. It's going to leave us with 3 10s. Here we come to our problem. We've obviously got 5 hundreds, and we need to subtract 900s. So what we're going to do is we are going to need to exchange that 1,000. And if we remember, that 1,000 is the equivalent of 10 hundreds. So we'll just put those over there for us. So let's have a look then. if we're looking just at our calculation here, this obviously becomes now 1,000, as we can see, and we've carried over our thousands. We've got 15 hundreds, take away 9. 2, 3, 4, 5, 6, 7, 8, 9. You can see one of those is under there, so we've got 6 left. So 15 subtract 9 is 6. We're left with our 1,000. We've got the same problem again here. 1,000 take away 7,000. We are unable to do. So once more, we're going to need to exchange it for a 10,000, and we can have those there like that, so we can see. So back to our calculating then, and coming over here, we've borrowed one, so we've left it with one 10,000. So we've got 30,000 left now. Carry over that 10,000. So we've got 11 take away 7,000. So we've got 3, 4, 5, 6, 7, which leaves us there with 4 and 3, with 30,000, 3 tens of thousands take away 2, leaves us with 1. So we've got 14,634, and definitely wanting to use a column method there, lots of exchanging happening and going on. Okay, next one then. Now this one, actually, when we look at this problem, it's not quite as tricky as it's made out to be, and this is where we might use our knowledge of place value, where we might be able to do it in our heads, and we might be able to use a small number of little jottings in order to help us. So I can see here that I haven't got any exchanging happening, and would I know what 44 take away 11 would be? Well, that would be 33. So if I'm looking at 44,000s, I've got 33,000. We can see that there. We're taking 1 off the tens of thousands and 1 off the thousands. So we've got our 33,000 there. Next up then, we're just taking away simply 200 or 200s from our 600 here. So we're taking away 2, which is not going to leave us any longer with 666, but 466. And we can see here, if we put those back together, we've got 33,466. It's up to you how you might want to do this. Another way to think about it is to write your number, 44,666, and think about what you're taking away. So can I take away the 11? Yeah. Can I take away the 200? Yeah. So that place value understanding actually is a way of doing that mentally in our heads, that we can see there's no exchanging. We can simply, like our example here, show that subtraction. Now finally then, this is one we haven't looked at for a little while, but I want you to look really closely at these two numbers, 24,005 and 23,998. Now to look with on the surface, you think, oh, column method, there's going to be some exchanging going on there, that's quite tricky. But if you look closer actually, you can do something called finding the difference. And the reason why that is because actually these two numbers are actually very close together, and if you place them on a number line they would be very close together. So we can do something called counting on, and I'm going to show you on my number line now what that would look like. So you'd start with your number 23,998, and you're going to think about the fact that actually it's only 2 here in order to get to 24,000. And then to get from 24,000 to 24,005, it's only another 5. So altogether, the difference between those two numbers is 5. And, you thinking about the inverse, if I was to do 23,998, add 5, my answer would be 24,005. So look out for those numbers that are actually quite close together, and see on number lines if you can find the difference. And that's probably going to be a lot quicker than using a column method, which would include lots of exchanging due to these digits here. So today then, similar to Wednesday's session, you have got a range of sums and you are going to organise them You're going to sort them into the most efficient method, the best method that you think you would use, and then have a go at solving them. I've also put rounding and adjusting on here, as that's another subtraction strategy we've been using, and some of you might find that you think, oh, some of these questions I could actually round and adjust if you're feeling confident with that. If you manage to get through all of that, there is a little reasoning challenge at the end, similar again to Wednesday. Can you find 2 ways to calculate this problem? So again, initially, I would probably go in with a column method, as they're quite large numbers as well. And let's work that out. So, 2 take away 3 ones I can't do. So I'm going to exchange here for 9. 4 take away 3 tens is 1 10. 5 hundreds take away 4 hundreds is 1. 8 take away 1,000 is 7,000. 70,000 take away 10,000 is 60,000. And my 100 stays the same. So I've got 167,019. Now, if I wanted to, another way I could do it is I could use my place value, possibly. Oh, it's going to be a bit complicated because I have got a little bit of exchange in there. But if I think to begin with, can I take 33 from 53? Sorry, from 52. Yes, I can. That's a difference of 19. So I've dealt with those. Then 500s take away 400s is 1. Dealt with those. And then 11 from 178 is going to be 167. Now it's saying explain which was the most efficient and why. Now I don't know about you, but that took quite a lot of thinking using that place value strategy, whereas the column method actually this time was much easier, particularly as it was bigger numbers and also because I had that exchanging. So if it asked me which was the most efficient, I would say the column method because there was some exchanging. There was room for error, I think, in my second place value example. So it's all about evaluating and thinking what it works best for you. We're all different as mathematicians and different ways help different people. So have a think, if you do get onto this problem, different ways you could go about it and which you think is the best for you, is the most accurate, the most efficient, maybe the most quickest. We look forward to seeing your work. Thank you.